Hello everyone, I hope everyone had a nice week and everyone is up to date. And this week we'll be meeting on Saturday and hopefully everyone brings a good question to discuss about. So today we're going to talk about the following thing. If I can find my mouse, here we go. So today we're going to talk about digital versus analog. And activity, we're going to do street light. So digital versus analog signal. Well, on the left, what signal do you see here? Can anyone recognize? Yeah, it's your heartbeat signal, okay? This is what your heart gives as a signal saying that it's beating properly. So what are signals? Well, data and information can be delivered by something called signals, okay? And there are two main types of signals we have, and one is analog. Now, analog signals are made up of continuous values, as you can see on the right. See, as the time goes by, the signal can be moved continuously. It can go up and down, and you can see that there's no gap, right? It's all continuous, meaning you're able to draw this graph without picking up your pencil if you were to draw this, right? So that's what it means to be analog. It's continuous. Now, another example of analog signal is what you see here. It's a light switch, but it's a slider. So as you can see, as you dial to the right or clockwise, it gets darker, right? But it's not on or off. But rather than that, it's actually it's gradient, meaning you can see the continuous change of light depending on where the dial is. So that would be an example of analog signal. Now, analog signal compared to digital signal is less reliable. Now, I want you to think about why that might be, and not necessarily you have to come up with an answer, but just think about it, okay? Remember, it can be also converted to digital signal through something called sampling. Don't worry about this, but just know that it's possible to convert analog to digital signal. So what is digital signal? Well, compared to analog, digital signal has two distinct values. It's either 0 or 1. So if it's 0, you can think of that as off. And if it's 1, you can think of that as, off is 0 and on is 1, okay? Now let's look at this graph here on the right top corner. Now, as you can see here, the graph is very different from analog signal graph, right? Look at this, continuous, right? But now we have rectangular shapes, right? It's either on the bottom or it's at the peak. And between, there's a jump. Now, even though there's a straight line there, it's a jump, okay? It means there's no value between these two. It's either 0 or 1, okay? Now, you can think of this as a light switch that can either be on or off. As you can see here, it's kind of distracting because it's flicking. But anyway, digital signals are, compared to analog signals, they're more reliable. That's why nowadays, most of the signals that we send within the communication device and also within the device is usually digital. And this digital concept of 0 and 1, it's called binary code. Bi means 2. So binary means there are two terms. It's either 0 or 1, and it's a language that we use to communicate with computers. So if you have watched videos or a movie where there's a lot of coding going on, programming going on, you'll see a bunch of zeros and ones, and that's how computers communicate. Now, moving on. I forgot to note here, it's possible to convert digital signal to analog signal, and it's done a lot actually in devices. Now, can you identify which device is digital or analog? Pause the video and think about it and resume after you're done. Okay, so hopefully you said something like this. The microphone is actually analog, okay? A microphone itself picks up voice, right? Our voice can be in very continuous, have continuous metrics. For example, our volume can be either high or low. It's not on or off. It can be anywhere between. And also our frequency, the pitch, can be also changed so that this device has to be able to pick up analog signal from our voice or outside signal, outside sound. And of course, if you want to analyze this, this analog signal can be converted to digital later on, but the microphone itself is analog. Now, what about TV? Now, TV is a tricky one because why? TV contains both analog and digital. Now, nowadays, the screen itself is digital, meaning when each pixel in your screen is depicting what color it is, it gets signal from the source, and that source signal is digital. It's all 0 and 1s, and depending on the value, it determines what color is how much. But of course, when the sound comes out, it's not digital sound. It's not like on, off. It's actually analog, right? Because the digital signal that contains sound information is converted to analog signal. So yeah, many devices that we have, they both contain analog and digital. Because why? We use them both. Okay. Exercise 1, identify which signal is an analog signal and a digital signal. Pause the video, come back when you're done. Maybe this was too easy. The first one is analog and the second one is digital. Please, there's clear distinction, right? Analog can be continuous. It can have any value between one point to the other, right? But digital can be either 0 or 1. 1 0 0 1 0 1 1 0 0. That's how computers pick up and communicate with us. And this can be challenging, but think about this. Given the following analog signal, think about how we might be able to convert it to digital signal. If you remember, I said digital analog signal can be converted to digital using something called sampling, right? Now, we didn't really talk about what sampling is, but think about how you might be able to do it. Pause the video, come back when you're done. Remember, this is a challenge, so don't spend too much time on it unless you want to. All right. Hopefully you came back after thinking a little bit at least. So briefly talking about sampling, what it does is depending on sampling rate. So sampling rate means how often do you want to sample? For example, let's sample this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 different sections, right? So what it does is divides into 13 sections, and at each value, right, at each peak, it gets values here. This value is 1, this value is 2, this value is about 2, this value is about 2, this is about 3, and so on, right? So I can write here, this value is 1, this value is 2, this value is 2, this value is 2, this value is 3, and for example, this value is 5, right? And I guess this value is 6, and so on, right? So at each sampling position, each one has a value. Now, even though there's value between here to here, here to here, we don't really care. We only care about positions where we're sampling. So only information that we'll have after digitize this signal, it's going to be 1, 2, 2, 2, 3, 5, 6. So instead of having all this continuous values, we now have distinctive values. But you might be asking, hey, that's not 0 and 1. So how do we convert this to 0 and 1? Well, if you look at these numbers above, those are binary numbers representing 1. So binary number for 1 is 1. Well, the reason why we have 0, 0 is like, well, I'm not going to get into that, but let's say they're just there for placement value. Now, binary number for 2 is 0, 1, 0. If you want to look more about binary number, Google it because it's pretty easy to learn. It's pretty fascinating, okay? Now, moving on 3, maybe we can do that during our meeting time. So 3, you can see that compared to 2, it has one extra 1, right? So 0, 1, 1 means 3. Now you can guess what 5 is, right? 5 is 1, 0, 1, and 6 is 1, 1, 0. That's how analog signal can be converted to digital, okay? Bunch of zeros and ones. Now, if you want to watch more about it, please click here and you can watch it with animation. But we're going to move on for now. So input devices. So from what we talked about in MakeKit, right? Hopefully you have the MakeKit by now. There are multiple input devices we talked about last time, but let's talk about this 4, okay? One is brightness sensor, and the other one is ultrasonic, and the other one is a switch. I guess they're same. So there are 3 different types. So think about what input device might be what type of signal. Pause the video, come back when you're done. All right, hopefully you guessed something like this. Intensity, analog. ultrasonic, analog. Switches, the digital. Now, the reason behind it is because light intensity can vary from really dark to really bright, and there are a lot of values in between, right? So it's analog. Now, ultrasonic, if you remember what it does, it measures distance using sound wave, okay? So it has to be able to pick up what distance is, not just is it far or close. No, we don't want that. We want exact distance. That's why ultrasonic should be, it makes sense that it is analog. Now, what about switch? Well, this switch are not dial switch. So this makes sense that this is digital because it's either on or off. All right, moving on. So let's get in deeper into light intensity sensor. Now, light intensity sensor, what it does is it senses intensity of light. Now, so as an output, it gives a value from 0 to 100, and closer to 100 simply means something the outside sensing light is really bright, and as you get lower to approaches to 0, that means it's dark, which makes sense. Moving on, ultrasonic sensor, what it does is it sends out sound wave. Now, when the sound wave travels along, like away from the sensor, when an object is obstructing the path of the sound, what it does is the sound reflects backward. It comes back to the sensor. And depending on how fast that happened, the sensor calculates how far an object might be located. Okay? So I guess I gave away most of the answer, but think about why it makes sense that ultrasonic wave sensor should be an analog, not digital. All right. Hopefully you're thinking about, well, in order to measure distance from varying distances, it makes sense that ultrasonic wave sensor should be an analog sensor. Okay. Now, the reason why we emphasize on analog versus digital is because if you look at your Arduino board, right? Now, I'll talk about this more in detail very soon. There are two different inputs. If you read through here, it's called digital sensors. And if you look at the bottom part, it's called analog sensors. So depending on what type of signal each device uses, you have to put the pin in the right position. The curriculum, just like before, we'll go to I am the ICT Fusion Maker and go to traffic light. So today what we'll need is the following. We need the Arduino board, power cable, any adapter to connect to your tablet or your smartphone, breadboard, male-to-male jumper cable, meaning both sides should have metal parts, and we have LED lights. And as before, just to remind you, the longer side is always the positive side, and the shorter one is the negative side. I'll remind you again later on. So let's create the circuit. First, you'll need the board and the breadboard. This time, let's zoom in here a little bit. As you can see here on the top, so we have negative row and we have positive row, and any place you place in the negative row is shared, meaning even if you put here or here or here, doesn't matter, they're all shared. And same thing for positive, doesn't matter where you plug in. Plugging in here, here, or here or there are same effect, same thing. Doesn't really matter, okay? As you can see also, the positive side will be connected to 5 volt, and this is where power is supplied. And the negative side is connected to the ground to complete the circuit. Okay, all right, let's move on. We add LED light. And notable thing that we need to make sure we do is that we add positive here, positive side, which is longer one, and we connect the positive to pin number pin number 5. Okay, and the negative side to the negative row, anywhere in the negative row. Okay, and remember, longer leg is positive. And next, do the same thing with yellow, but for the yellow, we connect the positive side to number 6, pin number 6. And for the green one, we will add the positive side to pin number 9. Now let's do block coding. This time we're gonna turn on red light for 1 second and turn it off. Ooh, let's zoom in so you can see. So remember, when you execute or turn it on and run this, always number one thing that the Arduino board does is what's in here afterwards goes to the forever. Okay, keep that in mind. This is number 2. All right. But anyway, our goal is to turn on the red light. So let's do it. So what we can do is a simple thing. Oops, just drag it, and red should be number 5, right? And turn it on. And then we wait 1 second. And then what do? We turn it off. And remember pin number 5, right? And we want to turn it off. And this will repeat forever. So if you just want to do it once, we put it here. If not, we put it here. Okay. If you look at the solution, it uses how much actual power you want, 500 or 0. But remember, 0 means it's essentially turned off. And so there are multiple ways to solve a single problem, okay? And it has 1 second waiting right after turning it off, which we didn't really need, but we'll need it for later part. So let's move on for now. So after red light, we're gonna turn on and off yellow light. Repeat 2 times on and off for 1 second, okay? So here, what we want to do is now we want to wait 1 second after turning off the red light, and then we want to repeat twice. What do we want to repeat? We want to repeat turning on the yellow light. So let's try using this time. The yellow light is number 6, if I remember, and wait 1 second, and then do the same thing, right? But wait, number 6. But you want to turn this off, right? And then we want to wait 1 more second. And zoom out a little bit. And there we go. So what happens if we run this is this. So first, it will check if there's anything in when Arduino is turned on. It doesn't have anything, so it goes to forever. And then it will turn on red light. And then wait 1 second, turn off, and wait 1 second. Then turn on yellow light, off. And then what happens? It says go back. Go back here because you want to repeat this twice. So this is second time. And then run this since this is second time. Next thing is to go back to the original one. Now, whenever you want to check what's going on, what you can do is you can click on the upload button on the top right. And then choose simulation with application and play. And you should see red light turn on and yellow light twice, and then repeat red light, then yellow light twice, just like what we wanted in the block coding. So you can always test your code using simulation, so don't forget that. Okay, let's move on. So that's the solution. All right, last part is this. After operation of red, yellow light, finally turn on the green light. Okay, So our goal is to do the same thing, but with green. Green is number 9. So let's put pin number 9. So let's do the same thing. Play with simulations to check our block coding. So let's see. Yellow light twice, green light, red light, yellow light twice, then green light, just like what we wanted. So now what we're going to do is we're going to use MakeIt to make our traffic light. Alright, let's start making our traffic light. So you're going to be needing your Arduino board and breadboard. And if you look at the breadboard, just make sure that the negative side is on the top, and then we have positive row right below the negative. Okay. And what we're going to do first is we'll connect the Arduino board and the breadboard just like the app. And make sure you have 2 wires, one at the top and the other one right below it. And brown is on the negative side, and black wire is in the positive side, the red one. So for the positive one, black wire, go to the power, 5 volt, and connect it. And for the brown one, which is connected to the negative, there are 2 ground. Doesn't matter which one, you just put one there, okay? If you cannot see it well here, go back to the app because it shows you where it is, okay? Just to repeat, black one is in the positive and connected to 5 volt, and brown one is in negative, the top row, and connected to the ground, GND. Okay, next. We'll need LED light. Now if you look at the LED light, there are 3 types, red, yellow, and today I'll use blue, but you can use green one. So if you look at one LED light, there are 2 legs, and you'll see that one leg is a little bit longer, just like I said before. And the longer leg is positive, and the shorter leg is negative. Okay? So we'll always put the positive side on the right. Okay? So we'll connect this to the breadboard. And what I'm going to do is I'm going to put LED positive to 22 and negative side to 21. You'll see 1 through all the numbers on the top if you look at the breadboard. You do not have to use these numbers, but that's what I'll be using if you want to follow along. We'll do the same thing for yellow. Positive 216 minus 215. Okay? Always positive to your right, just to be consistent. And blue one or green one, positive to 10 and minus 2, 9. And for each one, we'll connect the wires. Same columns, okay? 22, 21. Black one is with positive side, and white one is with negative. So white, which is connected to negative, just put it on the top row anywhere. And same thing for other LEDs. 16 and 15, right? 16 and 15. And 16 is purple, which is positive, and white one is with negative. So connect the wire, which is connected to negative, to the top row anywhere, okay? Because they're all shared, okay? And same thing with blue. So for you, it will be green, 9 and 10. So the 10 is green, which is positive, and yellow one is negative. So connect the negative to anywhere on the top row. And remember, the colors don't really matter. So we haven't connected 3 wires that are connected to positive because we'll connect them to the Arduino board. The green wire, which is green or blue LED light, we'll put it in number 9, pin number 9. And the purple wire, which is yellow LED, put it in number 6, pin number 6. And for the last one, the black wire connected to positive red light, connect to pin number 5. Just like that. Now, if you're having a hard time seeing it, look at the figure. Always LED is on the right side, okay? Just to be consistent. We now have red, yellow, and green. And make sure for red, yellow, blue, and know where what columns are, and connect the wires in the same column, okay? So anywhere jumper wire connected to the longer side, you have to connect it to the Arduino board. The negative side, which is the shorter one, all the wires have to go to the top row, which is the ground. If you're confused or if you need to go back to the video, please do so, okay? But if you have followed it, let's connect it to the power and send our code. To light means it's ready. And let's send our code to the Arduino board. Now you can see it's blinking, it's receiving, and it will execute our code. Yellow twice, and green light or blue here, and then repeat. Red, yellow light twice, and blue. And this will repeat forever. Now try this with different timing or different combinations, because I mean, it's all up to you. Next week, what we're gonna do is we'll make this even better so that this is more practical and even closer to what we see in traffic light. Okay? Everyone, good job, and we'll see you next week.